All right. Okay, I didn't plan this out, but let's just see how it goes. I'm just gonna try and do some of these last couple pages. Huh. All right. Okay, so you've got quadratics, but no, I guess you have absolute value. The parent function is that. So this thing has been shifted and stretched, and see. So it's been 1, 2, 3, 4 to the right, 2 down. So that's -4 and -2. So it's got to be A or B. C, it's got a slope of 3. So it's up 3, left 1, up 3, right 1. So definitely B. But if I'm going to use my hacky method, I'll probably just plug in some points. Like I could plug in this point. 4 or 5? 4. So I could try plugging in 4 into each of these. Let's see, 4, and I get -2. So that one has that vertex. That's a maybe. Like plugging 4. That one has that vertex. That's a maybe. I plug in 4, and it doesn't have that vertex, right? That's like -28 -2. So negative, that's way off. Out. So between those two, maybe I'll choose a different point. I'll look for one that's right on, probably right there. So I'll go 2. I'll try plugging in 2. 2 minus 4 is -2. +2. So this one gives me 0. So that's out. And I'll just check this one. If I plug in 2. 2 minus 4, -2. Absolute, +2. Yada, yada, yada. It gives me that number. So plug-in points. That's going to be a pretty handy method for multiple choice. What's the domain? I think I made some notes on this. Did I put them on here? Nope. But there's 3 functions with the domain limit. It's either, if it's a fraction, you take whatever's in the denominator and say, hey, that thing, it's not allowed to be 0. It doesn't have to be greater than 0 or less than 0 or anything like that. It just can't be 0. So this one just can't be -2. If I'm going to use my hacky method, of course, I want to plug in numbers. So I'll choose some of these things. Okay, this one says x has to be less than -2. So maybe I'll plug in a number that's in that domain, or maybe I'll plug one that's not in that domain. I'll try -1. Plug in -1, and I say, oh yeah, nothing goes wrong. That works. That's 4/1. So what do I do? And what if I plug in something to the left of -2, like -3? Wait. No, I've read -1 already says this one doesn't work. This one, it's not the right one. So if I plug in something, I try to violate this one. This one says x has to be greater than -2. So maybe I challenge it and I say, oh yeah. Well, what if I plug in something that's not greater than 2? Not greater than -2, like -3. Plug that in, that still works. So yeah, no, that's out. Okay. Right. Cruising. What's the result when the equation is solved for y? All right. So no hacky plug-in methods for this. We're just gonna have to use algebra, and solved for means get the y's together and then get y by itself. All right, so I'm going to add y to both sides. Let me zoom in on this thing. Add y. So 7y. I'm trying to go quick. Then you know what? I'm going to add x to both sides also. All right. So then just divide by 7. So I'll just erase that. Put it over 7. And that looks like the closest. But A is the one. All right. So looking at 22, it's a linear equation problem. And I see, 2 of them are in mx plus b and 2 are in point slope. So apparently you need to know point slope and slope intercept. Some people really don't like that point slope. I used to be like that. Now I kind of like it. Uh, I suppose the hacky method would be just to plug in this for x and this for y into each equation. And maybe it works in two of them, and then you got to plug in the other point to see if it works for that one. Which one should I do? I'm going to try the hacky method. All right, so all I'm going to do is just plug in 2 for this thing. So let's see if I can do it quickly. 2 minus 2 is 0. And then this whole thing is 0. And then y would equal -3. So that works for that first point. So yeah, let me just go ahead and try the second point. So I plug in -1. Let's see, -1 minus 2, -3. I guess it helps if you're quick at like doing all this little piddly math like this one. Put that over 1. If you're quick, the 3's cross out. You get -3 times -1, +4. I should just be able to do that in my head, right? Y plus 3 equals 4, y equals 1. So that works. So I'll just go with that. If I really wanted to be thorough, I'd probably, plug in some numbers and these other ones. In hindsight, maybe this one would have been easier to plug in ones. The real way to do it is to remember that slope is y2 minus y1 over x2 minus x1. See, that would be 1 minus 3 over -1 minus 2, or over -3. So I look through these. Which one has a slope of -4 over 3? Could this one and that one. Yeah, so much work. If you're doing point slope, the next step is just to plug in one of these points. Looks like they chose that one, so it's y minus y1 slope, and x minus x1. Yeah, definitely plugging in those points was easier. If you're using this form, you're supposed to plug in the slope you calculated, leave b as it is, and then take either of these points and plug it in, and then solve for b. Hopefully you know all that already. Let's see. That's a bunch of work. I don't know. It's going to be some rotten fraction, looks like. -3 equals -8 over 3. Yeah, I don't want to finish that, but it doesn't look like it's going to turn into either of those. All right, let's keep hustling. Get this thing done. Solve and write answers and solution set. All right. So this might be this is kind of another weird problem that we don't do every day. So we probably forget how to do it, right? So I try to just plug in some numbers. All right, so answer A, let's interpret that. This thing says it should work if x is a number less than -7.5, like -8, or a number greater than 3. It's a lot of work either way. So let's try it. Let's try and get good at plugging in numbers, good and fast. I'm going to try -8. And so -8, +16. So I get 21 minus 3. I can see, yeah, that one will work. So seems too close. Seems suspicious. All right, so I'm going to try a number just to the right of 7.5. I'm going to try plugging -7. So let's see, that turns into 19 minus 3. See, that also works. So that tells me like this thing's false. Yeah, maybe this seems too sloppy to be plugging in numbers. So I know on my number line, -8 and -7 both work. So maybe I'll look at these and I see which one of these will allow for that. Looks like this one says anything less than 2.5 should work. And these two numbers are both less than 2.5 and they worked. See, this one says the number has to be greater than negative 2.5. This is so much work. This thing says it's just these numbers that should work. So I've already proven that's not true. This one says pretty much the same thing. Numbers between negative 2.5 and 7.5 should work. So I know that's not. So that did kind of work out. See. Yeah. Maybe if you remember how this went, maybe if you learned this in class, you're supposed to get rid of the absolute value and just turn it into an equation. Solve it. 10. Trying to go super quick. So 10 minus 5, 5. Divide by negative 2. 2.5. Yeah, I forgot something. You're supposed to turn into two equations. See, this is too much of a pain in the butt. Do that. So it's going to turn to plus 10. Then when you get rid of the absolute value, you're supposed to make a second equation. Screen, huh? So now that I'm doing this, now the plugging in seems like the better method. Then you're supposed to draw a number line, and you've got these three regions. And you're just supposed to plug in any number from each of those regions, plug it into the original equation, and see which ones work. So maybe I'll plug in a negative 100. You can see I'll get a really big positive number, minus 3, so that one would work. Just put a check mark. Then I'll plug in 0. So I get 5 minus 0, so I get 5 minus 3, which is not greater than 7, so that one won't work. And I plug in some number over here, like I'll plug in 8. And yeah, I guess that'll work also. All right, so you pick your method. You decide. I think I would just plug in numbers. And maybe I should let this problem go, but maybe in hindsight, I would draw a number line and I would plug in all of these numbers. 2.5, negative 7.5, positive 7.5, and maybe I would test each of these regions and see which one matched. Okay, 24, finally. Yeah. Which is not true about the graph of f. F of x has a local max at 3. No. Oh, max of 3 at x equals 0. Ooh. I don't know. It doesn't look like it peaks out at 0, but it's pretty close. Let's see what the other ones. No absolute minimum. That is true. It's got a local minimum right there, but it keeps going down. Oh, it says which is not true. All right, so that's out. X-intercepts are at negative 1. Yep, 1 and 3. Okay, that is true. Local max of 8 at x equals 4. Definitely not true. Also, okay, max of 8 at x equals 4. Move 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that one kind of looks good also, but the graph clearly just keeps going up. So I'm gonna go with that one. This one looks like it's false because it doesn't look like it actually peaks out. It looks a little to the left, but I'm just gonna say that's actually at x equals 0. What's the slope of a line parallel to this line? Easy question. Awesome. I'm going to add x to both sides. I'm going to put it on the left side. So it looks like mx plus b, then divide both numbers by 3. I'm gonna use a fraction just so it looks like a slope. Could write it like that, but I want to see a number in front of that. Let's write it like that. All right, let's slope the line parallel. So just any slope of 1/3. All right, got some piecewise functions. So all we gotta do is plug in -3. And to do that, we see which domain -3 belongs to. So let me see, -3, yes, is less than -2. So this is the one. Let me just check it over here also. -3, no, that's not true. So I have to plug it in here. F of -3 equals 2 third root -3. It's going to be -8. Third root of -8 is -2. -2 times 2 is -4. And then come back for this one. I got to plug in -1. See, -1. No. -1. Yes. So I got to plug in -1 into this thing. Turns into √1, which is 1. Okay. So -4 plus 1, -3. All right. Object thrown upward from a height 4 feet. So I guess you're supposed to memorize this equation. I think we did this before. If it's in standard units, not metric, it's -16 e squared plus the initial velocity. It's always -16, but then they'll change the velocity and they give it to us 20 t plus the initial height of 4. At what time does it reach its maximum height? So that's going to be the vertex. -b/2a. Okay. So let's do it. So that's going to be -20 over screen. Doesn't matter. -20 over 2 times -16. 2. Reduce that to 10/16, which is 5/8, and it's positive. 5/8 seconds. And they didn't ask for the value of the maximum height, or they didn't ask for the maximum height, so they just asked for the time. So I can stop there. If they did ask for the height, I'd have to plug it back in. Calculate. Lucky. Write an equation for the line passing through. This one, you do the slope. All right, we need a line, so it's going to be either y equals mx plus b. Do that other one. I can see this is a special case. These both have the same x value. If I quickly imagine a graph, it's going to be 5, -1, and 5, 4. So I know it's going to be the vertical line. Vertical lines, it seems like it'd be y equals because it's vertical. I just realized you can't see my cursor. But that's all right. You'd think it'd be y equals, but vertical lines are actually x equals, and it's going to be x equals 5 in this case. All right. Oh, there we go, cursor. All right, graph has horizontal shift left. The equation would be that's the parent function. Yeah, we'll do the question. Horizontal shift left 1. So that looks like left 1, but no, that's right 1. Because if it's horizontal, it's the opposite of what you think it would be. So +1, +1. That one's out also. Vertical stretch of 5. That should be outside the parentheses, and that happens in the normal way. So this looks like a stretch, and it is a stretch. So it's vertical. Looks like the right one. So we'll just check that out for a second. So for x squared, I could put numbers like I'll do 5 and like 3x and then minus 7. All right, and I'll put a negative there. This one is a reflection about the x-axis. This is a vertical stretch. This is a horizontal stretch, but it's actually a horizontal shrink. Because the horizontal stuff is always the opposite of what you think it would be. This one's a vertical shift down 7 for shift. And there's one right there. I guess that'd be a horizontal. It looks like right 2, right? But the horizontal stuff opposite. So it's actually left 2. All right. So there's kind of these 4 positions. 2 of them are inside the function. 2 of them are outside. The ones that are inside are horizontal. The ones that are outside are vertical. And there's also 2 of them are multiplied, like these 2 are multiplied, and these 2 are added. The ones that are multiplied are stretches or compressions, or stretches or shrinks, however you say it, shrinks, compressions. Multiplication, stretch, add, subtract, shift. Maybe memorize that. If you need to write it down, write it down. Let's keep going. It's the range. So not domain. I guess you're supposed to know what this parent function looks like. Y equals root x. It's like that. But this one has been shifted to the left 2 and up 3. I'll just quickly left 2 and up 3. -2 and up 3. So the domain now, the original domain was 0 inclusive to infinity, but now it's been shifted left. So now the domain, which they're not asking for, I know, it is -2 infinity. But they're asking for the range, which has been shifted up to 3 to infinity, which is this one. It's not possible 0. That keyword possible, that's that thing where you take all the factors of this 1, 3, 3, 9, and divide by all the factors of this. So it's going to be, I'll start with the denominator of 1. So it's going to be 1, 3, and 9. 1, 3, 9. And I'll go back through them again. 1 over 2, 3 over 2, 9 over 2. And it's plus or minus any of these. So let's just look through. Okay, that one's in our list. So looking for one not in the list. So that guy, this one is in the list. That one is in the list. Determine the quotient remainder. Seems like we kind of did this one recently. We could do synthetic or long division. I noticed it's 5, 3, 1. So we need to put those zeros in there. So 4x to the 5th is 0, x to the 4th. -64, x to the 3rd, 0, x to the 2nd, 1, and -15. Synthetic, -4. Oop. Easy. -29. Hopefully it's our remainder. Let's see, hopefully that shows up in there. I don't see it. Oh my gosh. That's because it's -19. Math's so hard. All right, gotta be that answer. Yeah, that's tricky. If you make one little mistake, you're hosed. But luckily, it's multiple choice, so hopefully you'll know if it came out right. end behavior. So, oh. I don't know. Was I paused? I don't think I was paused, but let me just go through that. I just did synthetic division. And I got a remainder of -19, and I see that's my answer. So I bring down, multiply, add, multiply, add, multiply, add, multiply, add. Don't make small mistakes, but keep nice spacing. Don't forget those zeros for the placeholders because there's no x squared, there's no x fourth. Next one. End behavior to the 15th. Good. No biggie. No matter the exponent, positive, well, I mean, even odd, doesn't matter. We just have to look at the sign of the leading term. And if it's negative, that means that tells us on the right side it's going to be going down. So we can ignore all this. We can just look at the leading term. If it's negative, we know the right side end behavior is going to negative infinity. So let's see which of these has that. As x goes to the right, g goes to, nope, doesn't go up. As x goes to the right, up, no, that's not it. So it's one of these two. If it's odd, that means both sides will have opposite end behavior. So this one is odd, so the right side goes down. That means the left side's got to go up. Got this weird step in between, which doesn't matter. So on the left side, this x goes to the left. This one goes, nope, not that one. This one. Almost done. Final solutions. So that means eek. Do this one last. So you gotta factor it. It looks like there's a GCF. That's something. X squared plus. Looks like I should have taken out a 2 also. I'll just erase it. 2x x3 x2 x. So I guess normally from there I would go into long division, which I might have to anyway, where you do this possible zeros, but looks like this one might go with factoring by grouping. Right? Right there. Group these and pull out an x squared, x plus 1. Group those, pull out a 5, x plus 1. Cool, and hopefully you remember how this goes. It's 2x. It's kind of like you're factoring this out. So it's x plus 1. And what's left inside? There's the x squared and the 5. 0. Now I can do zero product property. So I set each of these equal to 0 separately. 2x equals 0, x equals 0. Skip it to the end, x equals -1. And this one, it'll be x equals plus or minus I root 5. It's like that guy right there. Nope, this guy. All right. Inverse, that's where you switch x and y, solve for y. So I get 3x plus 5. -1. Wait, oh, whoops. All right. Suppose the cheater method would be to just make up some number. Like 5 looks like it'd be really easy. I'll make up a number, I'll plug it in, and I get 0, right? I'll take 0 and I could plug it into each of these and see which one gives me back that original 5 that I plugged in. So it's definitely not easier. So probably could just ignore this part. So I'll plug in 0 and just make sure 3 times 0 plus 5. Yeah, it gives me my original 5 back. I'm not going to try the other ones. 36. Doesn't look too bad. I see a quadratic coming out of this. 2x squared minus 26x plus 84. See a GCF of 2. 13. And then I'm going to factor it. So it looks like I could even, some of these kind of give me a hint, but minus 6 and minus 7. X equals 6 and 7 in the end. And there's no 0. All right. I tried, telling, I uploaded a couple of these into Chat GPT and asked it for a practice test. Here's some of the output it gave me. So there's, if you want to practice some more. And you could do the same thing. It's pretty easy. I could even screenshot one of these and just paste it into Chat GPT. Spit something out. Okay, yeah, if you need any more, just on this practice test or make up your own practice test, just, of course, just send me a picture of any questions. I'll make a little video. Okay.